Hello and welcome to our second SAGIS training video. In this video, we are going to learn how to set up our first SAGIS model so it is ready to start our first simulation. The first thing I've done is to create an ArcGIS Pro project. I've called it Saglandia, which is the name of our test model that we're going to be using throughout this series of training videos. And it's simply a blank project with a blank map that we're going to use to set up our model. The first thing that we need to do is navigate to the Project tab, Options, and then SAGIS Settings, the fourth option that will appear once the add-in has been installed. In this window, we're going to indicate the paths to all of the databases that we saw in our previous video that constitute a valid SAGIS model. So the regional database, the common database, and the Lakes, Transitional Waters, and Coastal Waters national database. In order to input the paths, you can simply paste them in or use the folder icon to navigate to where those are, select them, click OK, and then they will appear. If the database path is incorrect or invalid, for example, if it contains non-valid characters, it will automatically appear in red and you'll have a message indicating that the path is invalid. We will also indicate a path for a geodatabase that will contain the outputs that SAGIS produces. To do this, my recommendation is to go to Current Settings and copy the path of the default geodatabase that has been created with the ArcGIS Pro project. So we would simply copy this path, come here, and then delete, or if it is blank, simply paste this path. This will ensure that we know always where our outputs are because they will be linked to the ArcGIS Pro project that we're working on. And then finally, input the path to this folder where the SIMCAT model executable is. It is important to make sure that this is not the path including the executable. We only want the folder that contains the executable. Once this information has been input into this form, we'll simply press OK and go back to our previous view. Once we have input the paths to the file databases that constitute the SAGIS model, the next thing that we're going to do is check which determinants have been set to be included in the next scenario. To do so, we'll navigate to the SIMCAT toolbox in the SAGIS tab and then to General Settings. This form will show us in the Determinant Settings drop-down a table where we can check which determinants are currently included. In our case, that is ammonia and phosphate. Generally, when we request a SAGIS model, we will know which determinants have been set up either by looking into the model or by checking the DAT file that accompanies the model, if there is one. If we want to change the determinants that are currently included in the next scenario, we navigate to SIMCAT Global Control Settings, and in this drop-down box at the top of the window, we can see all of the determinants that are set up in SAGIS. If we navigate to ammonia, for example, we can see that it is indeed included in this checkbox called Include under General Settings. If we navigate to a determinant that was not included, such as BOD, we'll see that the checkbox is unticked. If we wish to include BOD for the next simulation, for example, we would tick the checkbox and then press Apply. And now this setting has been saved. It is important to notice that if we navigate back to the General Settings window, the changes won't be reflected here until we open and update the model. Open and update will be the first process that we will generally run when we receive a SAGIS model, and we set it up for the first time. To run Open and Update, again on the SAGIS tab and the SIMCAT toolbox, we'll click the second option, Open and Update. This process is actually a series of subprocesses that will add all of the feature classes and layers to the map that allow us to easily query the SAGIS model data, and it will also update them with the information that is later used in the data file. When we press the Open and Update button, we'll get this window, which allows us to select different tables that we can use to update the SAGIS model feature classes that will be used again for the data file and therefore the scenario simulation data. When we do that, it is important to notice that it is perfectly okay to leave all of the options as none. In this case, the default tables will be used. And for most simulations, the default tables are the most logical option. So don't feel like if it is the first time that you're using SAGIS and running Open and Update, you need to know which tables to select. You can simply press Run, and that is enough. For slightly more advanced users, the water body flows table contains the table with the flows derived from the low flows dataset that will be used to calculate the hydrology in SimCat. The default option is the water body flow estimates table, and we can always use that one, and it is most likely the only one that is going to be present in all models. I will leave it as none for the moment. The rich flows, again, this table is optional. It probably won't exist in your model unless someone has created it for a very particular simulation purpose, and it contains alternative flows that can be used for ridges if there is a need to use bespoke flows for a particular scenario. Similarly, a bespoke table with specific headwater flows can be used if it is necessary for a particular scenario. River quality contains a table generally named sample point quality, which is the one selected, I reiterate, if we press none as it is the default. And this table contains the water quality observed data from generally the Environment Agency sampling, although we could include our own sampling if we wished to. The next one, discharge quality, as well as discharge flows, are the only two options where generally you may want to select a specific table. Discharge quality is usually named discharge quality in this exact manner as I'm showing in the screen. Now, what this table contains is the effluent quality as a mean and a standard deviation and a series of statistics. If we wish to use, instead of the observed or measured discharge effluent quality, the permitted discharge quality, that is what it is specified by the permit of a particular sewage streaming works, we would select discharge quality at permit. In our case, we're going to continue with none. Discharge flows is the exact same thing as discharge quality, but instead of effluent quality, effluent flow. Similarly, we can select the sim discharges table, or we could select the sim discharges consents table if it exists, which should contain, generally speaking, the permitted flows for that particular sewage streaming work or asset. In some other cases, we'll see alternatives to the tables, like in this case, sim discharges _1. The reason for this is that in some cases, again, modelers will create their own versions of the tables to be used for particular scenarios. If you need to create an alternative version of a table, you can use the same name as the default, adding any suffix that you want. The abstraction quantities contains specific data for abstractions. The default is called sim abstractions, and we can use none, so the default is selected or selected directly, like in the other cases. And reach targets, which contains the target for all the river reaches in the model for those determinants that it has been set up, generally orthophosphate, although we could do it for ammonia, BOD, and many more. I will not go into dissolved data at the moment because this is for more advanced users, and we'll tackle this in a future video. So finally, I am going to press run, and this will launch the process. When the process is launched, this one or any other process in SAGIS, it will take a few seconds for the process to check that all of the tables and all of the input information to that process is indeed found in the SAGIS model databases that we have indicated. Once that process has finished, we will see that it opens in the history of geoprocessing. And if we wish to see the status of the process as it runs, we can hover over it, which will produce this pop-up window that we can then, pressing this button, pop out. And then we can check the parameters that are being used for the process and the messages that the process is producing in real time as it runs. This could be useful if we want to understand where the process is at, and also if we want to retrieve any specific information that is often output as part of the messages of the process, and so on. Now the process is about to finish. I'll simply close the pop-up, which won't affect the geoprocessing. And now that it has finished, you can see how my map has been populated with all of these feature classes that contain the SAGIS model information. After Open and Update is run, the different feature classes in the SAGIS model will be input into our map as layers. I'm going to explain what the type of information contained into each one of these layers. Sim features contains information relating several different model features that will be included in the DAT file. The most important ones are probably the sewage streaming works, as well as river flow gauge data, water quality monitoring stations containing water quality data, industrial discharges, and abstractions. Two less important types of records in this sim features layer are the plotting points, which are points in the map where we are telling SimCAD that we want a result, but they're only used to record an output rather than to contain information that will be used in the simulation, as well as the now deprecated record type stream or tributary, which used to represent river reaches that were too small to be included in the model, and yet we would want to make sure that an input of flow was recorded at that point in the river. Our second layer is SAGIS Point Feature Load. This layer contains information about features, specifically assets, that are better represented as a load input to the model. That is, as opposite to sim features, where we represent assets such as sewage streaming works as a combination of flow and concentration, in SAGIS Point Feature Load will represent loads coming from, for example, again, sewage streaming works, as the amount of kilograms per year of a particular determinant that it is input into the river. This format is commonly used for intermittent sources, such as storm tanks or CSOs, although we can use it to represent smaller sites or small industrial sites. The next layer is SimLT sample point, which contain information on water quality related to lakes exclusively, as well as estuaries. The next 1, 2, 3, 4, 5, and 6 feature classes represent model structural components, that being the nodes that join the different river reaches together, the nodes marking the start or end of a lake, estuary, or coastal body, and then the centroids of different layers in the map. For the purposes of this video, we will not delve into these particular layers yet. So far, all of the feature classes that we have seen are point feature classes, that is, records which information is contained as a single point. This is because the open and update process will automatically add the layers to the map, including point features first, followed by line features, and then finally polygon features. This is also the way that, in general, ArcGIS Pro tends to add the extra feature classes that you add to the map automatically by ordering them, putting point features at the top, followed by line features, and then finally polygons. For this reason, the next feature class that we have in our contents pane right now is sim reaches, which shows the river reaches in your SAGIS model. The next one is sim local lake catchment, which indicates, as you can see here in the map, the local catchment area for this particular lake that it's linked to it. We got sim lakes, which represents the different lakes in your SAGIS model, followed by sim estuaries, representing the estuaries, and sim coastal, representing the coastal bodies. And then finally we got sim water bodies, which contains all of the water bodies in your model, and it's the most visible feature of any SAGIS model, splitting the water bodies into different types, again coastal, estuary, or river water bodies. Now, before we leave, if for any reason you lose one of the layers in your map, or you would like to just refresh the view of the map without having to run open and update again, the easiest way to do this is to go to the SimCAD toolbox and press refresh layers. So this is a very quick process that basically what we'll do is it will remove all of the SAGIS model feature classes. It won't touch any extra data that it's already in your map contents pane, and it will basically refresh them, reapplying the symbology if it has changed, and reordering them as they were previously. As an exercise, I would suggest that you try to set up a SAGIS model and run the open and update process. In particular, I recommend using the Saglandia model as it is small and it will make the process faster and easier. Many thanks for your time. I hope you have a great day. Happy modeling.